Hello guys, you want to start chapter 13, so lecture 31. In this chapter, you're going to talk about partial differential equations. So in this lecture, at first, I talk about separable partial differential equations, and then I talk about classification of linear second order partial differential equations or PDEs. In chapter 4, if you remember, we talk about ordinary differential equations and we solve ordinary differential equations using Laplace transform. So you know that in ordinary differential equations, we have just one independent variable. For example, if you remember, for example, if you have a function like f, which is function of x, and we have a function of we have g, which is function of x as well. So we have just one independent variable, which is x. And for example, this equation, the second derivative of f with respect to x squared plus derivative of, for example, g with respect to x equal to 0. This function is ODE because we have just one independent variable, which is x. But in this chapter, you're going to talk about partial differential equation or PDE. So in this case, we have more than one independent variable. For example, let's assume we have u, which is function of x and y. So we have two independent variables, x and y. And we have another function like v, which is a function of two variables as well. So it's a function of x and y. If we have one equation like a second derivative of u, for example, with respect to x and y plus, let's say, derivative of v with respect to, let's say, x equal to 0 or equal to anything or equal to x. So this one is partial differential equation. Why? Because we have two independent variables. So we have x and y as independent variables. So we want to talk about these type of equations. In general, partial differential equations can be categorized as linear and nonlinear. So we have linear partial differential equations and nonlinear PDE. In this chapter, we just want to talk about linear partial differential equations. So what's linear partial differential equations? If we let u denote the dependent variable and x and y the independent variables, then the general form of a linear second order partial differential equation is in this form. So it's a second derivative of u with respect to x plus b second derivative of u with respect to x and y plus c second derivative of u with respect to y plus d derivative of u with respect to x plus e derivative of u with respect to y plus fu is equal to g. It's a general form of a linear second order partial differential equation. So in this case, a, b, c, d, e, f, and g. So they are all constant or functions of x and y. So this equation can be homogeneous equation or non-homogeneous equation. If g is equal to 0, g is a function of x and y. So if g of x and y is equal to 0, we call this equation as one homogeneous equation. And if g of x and y is not equal to 0, this equation is non-homogeneous equation. So it's about linear equation, linear second order partial differential equation. So we have nonlinear PDE as well. So we are not talking about it in this chapter, but for nonlinear partial differential equation, one of the constant or one of the coefficients or all of them can be dependent variable. For example, these functions. So the second derivative of u with respect to x plus u, which is independent variable, second derivative of u with respect to x and y. It's just an example, equal to 0. So since here u is dependent variable, u is dependent variable. As a result, this partial differential equation is nonlinear. So now we have the general form of second order partial differential equation. Now we want to classify this equation. So if we have the standard form of linear second order partial differential equation, as we can see here, we can classify it. So we say that if b squared minus 4 times a times c is greater than 0, we call this equation as hyperbolic equation. And if b squared minus 4 times a times c is equal to 0, we call this equation as parabolic equation. If b squared minus 4ac is less than 0, then we call this equation as elliptic equation. For example, we want to classify following partial differential equation. We have a squared, which is a constant, times second derivative of u with respect to x is equal to second derivative of u with respect to t. We want to see if this equation is hyperbolic, parabolic, or elliptic equation. So at first I have to write it in the standard form. Just keep in mind that here our function u is a function of x and t. So that's why we call this equation as a partial differential equation, because we have two independent variables, x and t. So if I write it in the standard form, so we have a squared second derivative of u with respect to x minus second derivative of u with respect to t, it's equal to 0. If you compare this equation with the general form or with the standard form of linear second order partial differential equation, so you can see that a capital it's equal to a squared, b capital it's equal to 0, c capital it's equal to minus 1, d capital it's equal to 0, e it's equal to 0, f it's equal to 0, and g it's equal to 0. So in order to find the classification of this equation, so we have to find b squared minus 4ac it's equal to b squared, so it's 0 minus 4 times minus a is a squared times c is minus 1, so it's equal to 4a squared. So a squared is always positive. As a result, this guy 4a squared is always positive, so we can say that the equation is hyperbolic equation. So we have hyperbolic equation.